So we will be continuing with the 11th chapter. Okay, and
Ma'am,
the
didn't you say I
last,
was over?
no, it's not over. A couple last topics are left, and we have to finish that.
What
It's not over.
topic?
Um, the last couple of topics are left, like how to make parallel lines using set squares and compass, and those topics are left, like one or two sessions it needs. Okay, that topic needs one or two sessions, and then the chapter will be over. So right now, like I'm directly sharing the book PDF so that you can watch how it is like constructed, how to place all the things, how to place the set square, how to place the um, scale and everything. For that, I'll directly be sharing the book here on the screen. Okay, 1 minute. Yes. So, hope exercise 11.6 is done. Last time I gave it as homework. Have you all completed exercise 11.6?
I haven't.
Haven't? Okay.
No, ma'am,
So,
not yet. I'll do it today. I'm so sorry, but actually,
okay.
we're in Mumbai, so I'm not finding time because my grandfather's health is not well.
Okay. No problem. You guys can complete it. This weekend you can finish it. Okay. It's all right. Yes. So, drawing parallel lines. Now, this question, we are given one line. We are given, okay? That is L1. And one point is given, point P. You can see
I know
point
that
P.
you can
Okay.
draw one line and then put a set square in it, and then on the 90-degree side you draw a dotted line, and then you turn the set square around, and the one of the lines on the 90-degree side should be one
Yes,
should
you're
be
going correct. Mhm.
correct with the second line, and then you draw a line on that.
And you draw a line on that. Good, Simeon. That is correct. And we're going to do it today. We'll try it out. Okay, so in the question, we will be given one line and a point above that line. Okay, this is point P. Now we have to draw a line parallel to a given line L1, which passes through a given point P. Okay, passes through a given point P. So, um, have you all got your scale and set squares?
Yes, ma'am.
You guys can draw a straight line L1. Okay, first draw a straight line L1. Now mark a little bit above the line L1. Okay,
One
bit to
minute.
the left. Yes, yes, ma'am. You can see the diagram and mark point T.
Ma'am, ma'am, like I should draw
Yes.
any line.
Any centimeter, yes. Any measure. Just make it straight, okay?
Okay. Done, ma'am.
Okay.
It takes time for me, ma'am.
It's okay, you can do.
Okay, I'll try.
Yes, Samir. Hope you are able to do it.
Okay, ma'am. So I draw the line. Then,
Then the next thing,
ma'am,
place a set square. Yes,
ma'am, where should the P point be?
P point a little left above the line. Okay, you can name the line L1. P point will be like this, slightly towards the left side of the line. Okay, above the line.
Ma'am, ma'am, like this.
Yes, like that. Okay, like that you can do. Okay. Then next thing, place a set square in such a way that its one edge coincides with L1.
Okay, so
Okay, like this. Place the set square on the line. Don't place the scale right now. Okay.
X
Suppose
square.
this is your line. Yes, this is your line L1. Okay. This is your line L1. Place the set square like this on the line L1.
On the line L1.
Line
Yes.
L1. Yes, ma'am. Then, ma'am,
Okay.
ma'am, to the left side of the set square, P has has to be in the same line with the P point. Like this.
Not in not necessarily the same line with the P point. Okay. Just it should be on the line L1. It's one side
Anywhere,
of the
anywhere, anywhere on the line L1.
try to make it at the center, kind of like in the center,
Okay, ma'am. Here.
near the center. Then place a ruler along the other edge of the set square without displacing it. Now don't move the set square and place a ruler like this. Okay.
Another set square. Okay. So where, ma'am?
See, this is your line L1 that you have made. This is your set square that you have placed. Now, like your the edge of the set square, this edge of the set square and this edge of the scale should be touching. Okay, it should be placed joined together like this. Okay, and place your scale like this. Here,
Yeah. Done. Then.
done. Now, take 2 fingers of the other of your left hand. Place it on the scale like this to hold the scale in place. Okay, take 2 fingers. Okay,
Yeah.
index finger and thumb. Place it on the scale to hold it in place, and move the set square up till it touches the point P. Okay, take the set square up until it touch the edge, the upper edge of the set square. That is 1 minute. That is this edge of the set square should
Hello,
touch
ma'am.
your P point.
Hello, ma'am.
Hello.
Sorry,
You
ma'am.
draw two
Uh,
lines.
Sorry, ma'am. I'm late now.
it's
Yeah,
okay,
Two
Pranav.
lines that are
yeah.
parallel to each other.
Ma'am, yeah, touching the P point, ma'am. Now we're touching the P point.
Okay. So your it's touching the P point. You made it upright. You've slided
Hmm?
it up the set square. It will touch the P point. Now, now what will we do? keep the set square fixed at its place and draw a line L2 passing through P along the edge of the set square. Now, this line L2 you are going to draw, okay, L2 you are going to draw that is passing through point P. You can say that this line is passing through the P point, okay, along the edge of the set square, along the edge of the set square, okay.
Like it has to start from the P point and then go to the other side.
No. Not start from the P point. It will start a little left from the P point, then go through the P point and then elongate it towards the right.
Excuse me, ma'am, we have to draw the P point on L1 or L2?
See, you have drawn L1. Okay. You have drawn L1. Okay. Then place the set square like this. Okay, Abraham, draw a straight line. Draw a straight line, Abraham. Okay. And name it L1. Then mark a point P on it. Mark a point above it. Mark a point P like this. You can see here. This is the diagram. Mark a point P little bit above the line, to slightly towards the left and above the line L1. Okay. Then on L1, you take the set square and place it like this. Okay, take the set square and place it like this. Okay. Now, don't move the set square, hold it and place the scale here. Where? Here.
The left of the set square, ma'am.
Yes. Place the scale here. Like this. Okay.
So this will be a scale.
This is a scale. I have made a scale. Okay. This is a scale. The scale, the edge of the scale and the set square should be touching like this. Okay. Now put two fingers on the scale and move this set square
Until
up
it touches P. Until it touches P.
until it touches the P point. Okay. We will move this set square, slide it up, okay, until it touches P. So now what it will become, what it will look like. I'll draw and show you. It
Like
will
this.
look like, 1 minute.
Ma'am, for me it looked like this.
Okay. So you will slide your set square up. Okay. This is the set square that has up. Okay. The slided up set square. Now you can see that the edge of the set square is cutting through P. Now from here draw a line. Okay. From here draw a line like this. The set square edge from the edge of the set square like this. Okay. This line where the set square you will place, draw a line like this. Okay. Then it will be L.
2.
Okay.
No,
This
ma'am,
is clear.
I'm not understanding.
Okay, no problem. Rest of you all, I'll explain Abraham. Rest of you, are you able to get the parallel line L2?
Yes,
Yes.
ma'am. I got it.
Okay, Anaya, you got it?
Ma'am, but I don't have a set square right now.
Okay, so you can do it later. Okay, you can try it out later.
Ma'am,
All
here.
right. Yes, that is right. That's right, Edric. Yes. So see, Abraham. Now what we did, um, yes. So the question is saying that a line is given to us. Okay. A line is given to us we have to make another line that is parallel to that line. Okay, and above that line, point P is given. Okay, this line L1 is given to us, and this P point is given to us. What question is telling us that draw a line through the P point which is parallel to L1. Okay, draw a line through P point which is parallel to L1. So first thing you need to do is draw a straight line. Okay, any measure, any centimeter, draw a straight line.
Where? In the textbook or the notebook?
In the in the notebook.
Ma'am, should I draw it like on the topmost parts or like the lowest parts?
Draw it in the middle of the page.
The middle, ma'am.
Yes.
That is because my book is it's pretty small. That's fine.
Okay.
Okay, ma'am. Then
Okay. Then name it L1. L1.
L1.
Now, yes, above your line, leave three lines. Okay, where you have drawn the line now.
Yes, ma'am.
Above that, leave three lines and mark a point P on it, like this. Mark a point P on it. Okay, this is slightly towards the left. Mark a point P.
Ma'am, above.
Above.
Yes, ma'am.
Okay, done?
Yes, ma'am.
Now, take your set square. Okay, put the longer side on the line like this.
Ma'am, which one? This.
Yes, this one you can do.
Ma'am, this one or this one?
The other one. No, the other one. Yes, that one.
Yes, ma'am.
Okay, you have placed it like this on the line.
Yes, ma'am.
Now take your scale. Okay, how will you put the scale? How will you place the scale? I will show you. I'm making the scale in blue color. Okay,
Here.
you will place here. Yes, here on this line like this. Okay, and here like this. You put your scale near the set square. Okay, done.
Yes, ma'am.
Now take two fingers, place it on the scale to hold it. Okay, to hold it. And with one hand, with your right hand, move the set square above till it touches your P point, till this line of the set square. 1 second. Till this line of the set square is touching your P point. Move it up. So it will kind of look like this. Just a minute. It will look like the set square is going to look like this. Okay, touching the T point. Okay, now where the edge of the set square is touching the P point, that from there only you draw a straight line. Okay, like this. I'm drawing it over the maroon line, a red line. Okay, like this, making it. Okay, and mark it L. This is basically drawing a parallel line using set square. We also have drawing a parallel line using a compass. That also we are having. So we will take a look at that too. Okay. Done, Abraham. Now join that join the line L. You'll get a line L2. Yes, got it? Okay, done. So this is how you do it. Now we will see how to draw it with the help of compass. Okay. Now, with the help of compass, we are going to use which property? The equality of alternate angles. We know that alternate angles are equal, right? So we are going to construct alternate angles and then draw parallel lines. Right? We studied about this property of alternate angles. That alternate angles which are formed between two parallel lines are equal. So when we will construct two alternate angles, then the parallel lines which will be formed will also be the lines which will be formed will also be parallel. Okay. So this is what we are going to do. Now, question is draw a line parallel to a given line L1 which passes through a given point T. Okay, which passes through a given point P. Now, what does it mean passes through a given point P? See, this is the line L1. Again, step 1, draw a line L1. Okay, draw a line L1. Any measurement. Okay, and draw a line L1. Now,
Yes, ma'am.
take a
Finished.
point. Okay, now take a point A on the line L1. Mark first leave 4 lines above 4 to 5 lines above the L1 and then towards little bit towards the right mark point P.
Ma'am, where mark the A point and the P point?
First mark the P point. Leave 4 to 5 lines above the line that you have drawn L1, above L1. Leave 4 to 5 lines and then mark a point P slightly towards the right. Slightly towards the right from the center. Okay, like it should be from the center. It should be more towards the right side.
Ma'am, like this, ma'am.
Yes. Okay. Now, next thing. Now mark a point on L1. You can take it in the center or near the center. A point on the line L1.
Ma'am, anywhere near the center or no?
Anywhere near the center, but it should be near the center.
Okay, ma'am.
Now take your compass. Yes, will work. Now take your compass and put the compass point on A. Put the compass point on A. And then draw an arc like this. Okay. Also, please join A and P. Please join point A, that is this one that you marked, and point P on the top. Please join them.
Yes, ma'am. So I have to join A and P.
Yes, join A and P. Then put the compass on A point and then mark an arc like this.
Where?
Here. Here like this.
Only a small arc? Or no?
Small arc, yes. Smaller radius, radii, you will have to take on the compass. Okay, smaller radii. Um,
Ma'am?
Yes, Abraham, but your P point, not up, Edric, not there. First join A and P.
Yeah, okay, ma'am.
Okay, and
Okay.
Abraham, make your P point towards the right. It's more towards the left. Make it towards the right side.
Okay, so now I done P and A.
Yes. Now put your compass point on A, the sharper point on A, and then make a small arc here like this. Like
Ma'am, which side do you have to draw P? Again on the left side or the right side?
on the right side, your right side. Then join it with A. Join P and A. Then with A as center, cut an arc like this.
Ma'am?
Yes.
Like this, ma'am?
Yes, like that.
Okay, ma'am.
You are muted.
Ma'am, how
Yes.
to cut an arc, ma'am? Like top point, ma'am. Like, does it have to be? Does the arc have to touch point P?
Does the arc have to touch point P? The arc has to touch the line AP. The line AP it has to touch. Okay,
The
not the
line
P
between
point.
the A point and the B point.
Yes, the line between the A point and the P point it has to touch.
Okay, ma'am. And can we keep the same radii?
Yes, you have to keep the same radii. Don't change the radii. Okay, we will need the same radii. Now, taking P as the center and the same radius, draw an arc which intersects PA at B. Okay, draw an arc which intersects PA at B. Didn't got it.
When
Okay.
did D
Ma'am, what
come?
should be the center? Ma'am, same radius, but what should be the center?
P point. Right now, you drew an arc with A point. Now, put
Yeah.
your compass on the P point and cut an arc that is cutting again this line AP, like this.
Okay, ma'am. So another small arc. Okay.
Another small arc cutting the line AP with um, P as the center. Mark this point B point. Okay, this point here is the B point. And this angle, you can name it angle 1. Angle 1. Simran, hope you are able to make it. Okay.
Ma'am,
Yes.
so here the B point here.
Cut it through, like cut the arc through B. Yes.
So, like, okay.
Which intersects PA at point B. Cut the arc BC so that angle 2 is formed at P. And angle 1 formed at point A are
Okay.
equal.
Okay. Now, through B.
Now, cut the arc BC so that angle 2 formed at P and angle 1. Okay, so your it will be like this, okay? And draw a line, join P with C and extend it on both sides. Now you are having two alternate angles, okay? You can name it angle 2. This one, you can name it angle.
Ma'am, I'm not understanding.
Not understand. Till here, have you made this angle?
Ma'am,
B
yeah.
angle, have you?
Ma'am, if
Ma'am,
you
I've
cut
done
an
till B,
arc
ma'am.
from angle B,
One
Ma'am, I've
minute,
done
Eddie.
till B. I've done till B, ma'am.
ma'am, you have
Okay,
to cut an
Yes,
arc
Abraham.
from B.
No. From P point. Cut an arc from the P point. Place the compass pointed part on the P and make an arc like this. It should cut the like this. It should cut the line AP. So, um, okay.
Ma'am,
Show
is it?
again, Abraham. Abraham, show again. Here is the and here is that. Okay. Yes, Abraham. All right, got it.
Okay, ma'am.
So, it will look like this. Your angle, your diagram will kind of look like this. Now,
Ma'am,
name this angle P. Two. Okay. Yes. Yes, Edric. Okay. Now put one bit in the below one and two inside the above one.
Ma'am,
Yes, Abraham.
my diagram is completely opposite, ma'am.
Your diagram is completely opposite.
Yes, ma'am. Ma'am, instead of the one being on on this side, ma'am, on the left side, it's on the right side. It had to be on the left side, ma'am.
The yes, it should be on the left side. Hmm.
Okay, ma'am.
okay, ma'am. So I named it 1 and 2. So then
Yes,
next,
name it 1 and 2. So
then
now angle 1 and 2 will be equal. Okay, angle 1 and 2 will be equal. Now do what? Make a line through P, cutting the arc through P, cutting the above arc. How? Like this.
ma'am, 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 should I make a line through
Um,
P cutting the arc 2?
yes, like 1 minute.
Up, little up, little up, little up. Oh yeah, like that, like that, like that, like that, like that. No.
Yes, like this. Okay, you have to make it. Name it L2. And
Ma'am, L2 is the parallel line.
L2 is the parallel line. Okay.
But ma'am, how I have a question, ma'am. But since we're doing this on a rule book, ma'am, it'll be very easy to gauge the parallel, which is the parallel line. But if I'm doing this on a blank paper, ma'am, how will I gauge, ma'am? Like from where to draw it?
If you are doing it on a blank paper, you first need to draw a straight line, okay, of any measure. Then I think the set square method is better instead of the compass method. The like you can directly use the set square method, put the scale and then take it, drag it up till the point you are having, and then just draw a line through it. Okay, so on a plain paper you will get a parallel line using the set square method. Using this compass method, it's a bit tricky. Okay, and I don't think questions like this are asked in your exams. Okay, from this chapter, this is a part that is not that important. Okay, we are just learning it because it is there in the syllabus. Okay, but major what we did before, like up till now in this chapter, was like more important compared to this part. Okay, so yes, so we will have a parallel line like this. Okay, now
Okay, ma'am, got the parallel line, ma'am.
okay, so Edric, show yours once. Correct. Now, Edric, where L2, where your arc is touching L2, name that point C.
Okay, ma'am. C.
Okay, that will be C point, everyone. Where your arc is touching, I will make and show. Suppose this is my parallel line. This is my parallel line. And here is my 1 minute. Here is my R2. So this point will be C point and this point will be P. Okay. And this line is L2. Yes. Okay. So this is how we can make it with compass. Okay. And what angles are forming in between? Alternate angles are forming. Okay. Alternate angles are forming in between them. Now, there is one more thing in this chapter.
Is there another method or no?
There is another method, I think so, using the quality of corresponding angles. And then how to do perpendicular lines too. There is a method on how to do how to draw perpendicular lines. Okay,
Ma'am,
using the
there are how many?
protractor.
Ma'am, perpendicular lines can only be drawn using protractor or no?
Using a set square also. It can be drawn using a protractor and using a set square. Two
Okay, ma'am, so
methods are there.
two methods for
So
this one, and
I
again two methods for drawing parallel lines.
I
The
never
screen was
understood what's
slightly going dark in
perpendicular.
between.
Ma'am,
1 second. Yes, Abraham.
I don't understand what's perpendicular lines.
You don't understand what's perpendicular lines. Okay. So I'll explain you. Just a minute.
The screen was suddenly going dark in between.
Now it's fine?
Yeah.
Okay. Yes. So if there is a right angle between two lines, then they are called perpendicular lines.
Ma'am,
Basically,
ma'am, perpendicular lines always meet with 90 degrees.
yes. Can you see if you're having a line and a straight line on it?
Yeah.
What are the two angles that are made? 90 degree
Yeah.
and 90 degree.
Yeah.
So these are perpendicular lines. Or if I make the diagram like this, if I make the diagram like this,
X. Try to make it like an X or something.
one line is there, okay, and it's like a T, okay. So here
Ma'am,
90
X.
degrees forming, and here also 90 degrees forming. So again, these are perpendicular lines. Okay?
Ma'am, ma'am, X
Yes,
also. Ma'am, X
X
also.
also. Yes, X also here. X also or a plus sign also. All 90-degree angles are forming, right? Because with 90-degree angles form when do they form? When it is like a straight line they form this. Okay. So 90-degree angles are forming. So those are all perpendicular lines.
Ma'am,
Okay.
L. Ma'am, L.
L. L, yes. L is definitely a perpendicular line.
Ma'am, is
Okay.
E even a perpendicular line? E and F?
E and F.
L, T, F, G, H, I.
E, yes, E can be a
H
E
and I.
can be
Ma'am, H
1
and
minute.
I. Ma'am, H and I.
Here 290 degree are forming and here 190 degrees forming. F can be 2. H can also be a perpendicular
Also,
line. So yes,
outside the right
outside
angle
the
on the other side, it's making 270 degrees.
yes, on the other side. Yes, that is right. On the other side, it's making 270. This part Simeon's talking about. This part. The other side is making 270.
Ma'am,
Yes.
ma'am, ma'am, angles on a straight line always make 180 and angles on a point always make 360.
Yes, that is right. Okay, so we have studied that, and tomorrow we will learn how to construct perpendicular lines. That is on Monday.
Um,
We'll finish this chapter next week. Okay.
Okay, ma'am.
When are the test results coming?
So another test results coming today. One test today and the other tomorrow.
Which test today?
Science test today, ma'am, is it?
Science test today. Science test first I took, right? Yes.
Yeah.
Science test today and maths test tomorrow. Okay. Okay. See you all then. See you all next week. Bye.
Bye,
Have a good
ma'am.
There's no
weekend.
Thank you, ma'am.
science
Bye.
today.
Sorry.
There's no science class today.
Oh, the science class is there today. Edric, I'll see you in the
That's
next
why I
class.
wondered why you were saying bye, everyone.
Bye, ma'am.
Bye. 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 Yes, you all are staying. Okay. A 5 minutes break and then we will come.
Okay, bye, ma'am.
Okay. Don't leave, huh? Science class is there. Okay, hope you all are there. We are going to begin now. Videos on, please. Abraham Sunil. Hope you guys are there.
Yeah.
Yeah. Okay. So in the last class, we talked about different types of motion. Different types of motion we talked about, such as irregular motion, linear motion, rotational motion, circular motion, oscillatory motion. Okay, we saw about all of them. We talked about things that are moving and things that are static. Okay, today we will talk about length and measurement of distance. Okay, measurement of distance basically. Okay, now suppose, for example, this is a person. Okay, this person moved here, went on the road, okay, and reached here, okay. So this is the length that this person covered, okay. This is the length that this person covered, which is known as distance. This is known as distance, which is basically when an object moves on a path from one place to another, then the length covered by that object is called distance. Okay. So this person moved on this path. Okay. Before he was here in this place, he came to this place. Okay. So this was the length covered by him. Okay. Suppose the length covered by him is 1 kilometer, 1 km. Okay. So this will be the distance that he has moved. Okay. The distance that he moved. 1 kilometer. Alright. Now, whenever we see a dynamic thing, we can say it changes its position with time. Okay. What does it mean when I say that something is dynamic? It means that it keeps on changing. Okay. Keeps on changing. People use dynamic such as a dynamic environment, they say. Okay. Um, Dynamic culture, they say. All right, because some things they keep changing. All right, then measuring length or distance. Now,
Ma'am, I have a question.
yes,
Ma'am, so ma'am, what does it mean? Like it says air. They sometimes say aerodynamic.
aerodynamic. Yes, Anaya.
Abraham, what do you say? What is aerodynamic?
So like if dynamic means changing on the time. So aerodynamic has to do something with change, but I don't think it does do something with change.
No. Aerodynamic
Yes.
means. Mom, doesn't aerodynamic mean the
Something about
shape
flight,
in
I
which
forgot exactly
flying
what it was.
The
creatures
ship,
are? I mean, like aerodynamic is the shape which allows flying creatures to fly. Like to be able to fly, you need to be in a specific shape. Shape is called being aerodynamic.
to have a specific shape, okay, but aerodynamic is this it's basically the like study about the things that move through air, okay, because the word aero is there, okay, And dynamic is means changing. So in aerodynamic, it's basically it's talked about the things that move in the air, aeroplane or planes or any aircrafts. Okay, it is a study of those things that move through the air. That is basically aerodynamics.
Really, ma'am? Because I thought that I had read that aerodynamic is the shape in which flying, that you need to have to be able to fly or like move in the air.
No,
Okay.
no, no. I had read something and I had seen some videos where the car has to be aerodynamic, race cars have to be aerodynamic so they can move through the, like, they can be faster. So the air
They can
doesn't
be
slow them
fast
down.
so that the air doesn't slow them down. Okay, so it could be that it's about shape also, of the shape also sometimes. But if you were talking about the field of study, the aerodynamics, the whole thing, the whole era of it, it's basically about the things that move through air. Okay, study of all of that, and the study of the gases also present in the atmosphere and how that thing is going to move through them in the environment, in the airspace. Okay, so it is a study of that. All right. Um, read a like read a bit about the shape thing. Okay, I'll look it up too if it's also about the shape of a plane and a race car, so that it helps to move. It is about like the plane is shaped in such a way that it helps it to cut through the air and move in a particular direction. Yes,
Ma'am,
Abraham.
also the race car is because they have like the spoilers that cut through the air.
That cuts through the air. Yes, that is right. That cuts through the air. It helps to move them faster because the force is a lot. Okay. Now, yes. So a tailor measures the length of a cloth to know whether it's sufficient for a kurta or not. When we want to, we have purchased a dress material and we want to like get a dress made of it. Okay, anything, a kurti or a dress, a shirt or anything. The tailor measures us. Okay, they measure our sleeve, our waist, and everything so that it fits us. Okay, so that the cloth, then he, according to our measurement, he cuts the cloth and stitches it. Okay, so that is another measurement of length. A carpenter measures the length and width of an almirah to know how much wood is required for it.
But
Okay,
how does he measure it? Like he doesn't know, he hasn't already made it, so how will he measure it?
he hasn't already made it. I think the measurement is in his mind that this much length almirah I need, and then he measures the wood, okay, of that much length, 5 feet or 4 feet. He measures the wood and then makes the almirah out of it. I think it's written in reversed, it's written somehow. Yes, Nandini. Or if it is like the base is made and the wood he needs to put on it, like the extra material and all that, okay, then he can do that. Yes, Abraham.
Ma'am, my father likes to do woodworking as a hobby. So, ma'am, when he's creating something, he first thinks of the project and then he think about the centimeters and the degrees, and then he'll use mathematics to get the correct like angles and all, and the lengths wise, and then he also draw it on paper so that he can see his paper drawing and then as like that cut off the pieces of wood.
Mm-hmm. Yes, that is right, Abraham. They see the length, the angle, degree, and everything of something before making it, okay? And then they measure it and then make. Yes. Now, in older times, tools of measurement were length of foot, width of a finger, one step ahead, etc. Okay. In olden times, they used to measure it. Can you see your palm? Okay. from the tip of the longest finger to the bottom of the palm, they used to measure it. It was used as a measurement. Okay. Then they used to measure like from the tip of the longest finger till your elbow. They used to measure with this also. This is known as handspan. Okay. This is known as handspan. Then with foot, it is measured. It's still measured with foot sometimes. Okay. With your feet, the length of the feet, it's measured. Okay. And they were used in ancient times. Now we have inch tapes and all. Okay, to measure big scale rulers or inch tapes and everything we are having to measure the distance. Now, foot is used as a unit of measurement of distance or length in various corners of the world. Foot is still used. People measure 3 feet is equal to 1 yard. Okay, 3 feet is equal to 1 yard. People measure 1 yard by measure of cloth from chin to open hand. Okay, they used to measure it. Now, Romans used to measure the length by their steps, but every human being has different body structure. How can it be used to measure the length? We know that different humans are having different structure. If somebody is very tall, their hands will be tall. Somebody is shorter in height, their hands will be shorter. So, won't it create a difference? Like if there is not, it's not fixed to measure it the measure the length or the distance with the help of body parts because it is different for everyone, right? So they created the measurement system, okay, a set standard they created, which is now used. Due to this problem, French started measurement in 1790. Their standard tool is known as meter system. Okay, for uniformity
Meter system
measurement.
is what we use, right?
Yes, meter system is what we use. Okay, centimeter, meter, millimeter. Okay, all that. Then, for uniformity measurement, various scientists of world prepared a standard system of measurement. This is known as the international system. This is used across the world. The SI standard of length and distance is meter. To measure a bigger length 10 times, 100 times, and 1000 times of meter measurement is used. To measure a smaller unit, 1/10, 100th, and 1000th part of meter is used. So let's understand it. Now, basically, like we all have an idea of measurement, right? It's done in meter, okay? Then it's done like in centimeter, it's done in inch, it's done in very small, it's millimeter, okay? Then for the greater distances and the distances of places, we use kilometer, okay, or miles, all right? For one place to another distance, the measurement is the standard is kilometer or miles, okay, and all of that. That is the present that we are using right now. Now, in our day-to-day life, we use various methods for measurement. Meter is used as length measurement, tailor measurement, and cloth measurement. Therefore, distance covered by an object is fixed. Now, the same is called motion. Distance covered by an object is also known as motion. Okay, we just studied at the beginning of the chapter, right? So, motion is equals to distance upon time. Okay, and it is which is equal to meter upon second. Okay, like how many meters you cover in how much time. This is distance upon time is same as meter and meter by second. How? Distance is measured in meter. Okay. And time is measured in seconds, minutes, or hours, whatever. Okay. So when you divide the meter by that time measurement, you will get the motion. SI technique makes meter as a qualifier of distance and second as standard units of time. Basically, seconds are used as the standard unit of time. according to the this standard, seconds is used. Okay, therefore, a standard unit of motion is meter per second. Have you heard about it? How many meter per second it covers? How much distance it covers in meter per second, MPS. Heard about it now?
I wrote kilometers per hour.
kph, kilometers per hour. Yes, that is also used here. Kilometer per hour for the distance. For motion, meter per second. Okay. Now you have to try out 15.2. Please try it out. Homework. Okay. Now, don't go too deep into this. Okay, and no need to get confused of like how, where, calculation or anything. We all have studied measurement, okay, units of measurement and the standards of measurement. We have studied, okay, the international standard and everything. We know, all right, how things are measured, what standards are measured. So it's just a thing that you have to just remember, okay. Don't get confused, please. Yes. Then we are having force pushing, okay. Now, there are a few words that are used to explain some activities like pulling, pushing, kick, attack, etc. These activities create a difference in the motion or create a difference in the motion of the object. Can we use one or more words to express these activities? Okay, so now this person is standing behind the car. First image, person is standing behind the car. Car is in what? Static position. Now, second image, a person is pushing the car. Okay, person is pushing the car. So the car which was in static position will move. The car which was in static position before will move. Is it moving on its own? No, it's not moving on its own. Person who's standing behind it is pushing it. Okay, so then it's moving. So how is it happening? Due to a factor known as force. Due to a factor known as force. When the person is putting force and pushing it forward, the car is moving. Okay. Now, the pushing or pulling of an item in science is known as force. Okay. Now, car starts moving in the direction of movement. The person stops pushing the car. The movement of the car stops. Now, if the person will stop pushing the car, what will happen? It will stop moving. Okay, the car will stop moving only. So, why? Because the force has stopped. Pushing of the force that was being used while the car was being pushed has stopped. Okay, now push an heavy item to move it in motion. Now, if suppose two people are moving something on the opposite directions. Okay. This person is moving the table in this direction and he is moving the table in this direction. So what do you think will happen? Anyone? What do you think will
It
happen?
won't move at all. If it is the same force.
Yeah, ma'am. Or,
Yes.
ma'am, either they may just break the table if the table is delicate.
Mm-hmm.
But, ma'am, if like
Yes.
one person pushing more with more force, he will push the other person out.
Yes, that is right. Okay. If they are same forces being applied and the force is being applied in opposite directions, the thing will not move. Okay. But if they both move it in one direction, If they both move it in one direction, what will happen? The table will move to this side. Okay, because the force is being applied to move it towards one direction. But if opposite forces are applied, then the thing won't move. Okay, if the forces are equal. But if opposite forces are applied, when the greater force, the thing will move towards the greater force. Okay, this is about pushing. Now let's talk about pulling. Okay,
It will move with the greater force or toward the greater force. I didn't understand that.
if we are pushing it, okay, suppose let's take a look at these two people now. Okay, now suppose this person has greater force, greater power, greater force. He's pushing it towards the greater force with greater force. Then the
Oh, no, I got it.
thing will move in this direction. Okay, but then he pushes it again. He will move to this direction again. Okay, so for it to move forward, to take the table forward, both of them need to push in the same direction. Okay. Now, force is applied in pushing also, in pulling also. Okay, in pushing and pulling, both force is used. Have you ever seen this game where people pull the rope and the team towards which it goes wins?
Yes, ma'am, I've seen it and I've played it, ma'am.
You played it. Okay.
But ma'am,
So
your hands are with the rope.
the hands are,
Your hands start to hurt with the rope.
yes, you stand. Our hands start to hurt with the rope. Yes, they
They
do.
become red. That's why you feel like and if you wear gloves, the rope starts to slip.
Yes, that is correct. Now, see, this is the pull that's taking place. Okay. Now, this team is pulling it towards them, and this team is pulling the rope towards them. Okay. So, two forces are
I think the
exerted.
right side team is having greater force.
Yes, it looks like the right side team is having the greater force because of their faces. I think so.
No, because of the red dot you drew.
Because of, okay, because of the dot I
It
drew.
is little more to the right.
Yes. I didn't saw that while making it. Okay. Anyways, so the team which pulls more or exerts more pressure will win the game. The team who pulls harder, the red thing will come towards their side, and they are going to win, obviously. Okay. A rope will come to the team who is putting greater force. Okay, who is exerting more pressure. Now, if two forces are exerted in different directions, then the total force is equal to the difference between both the forces. Okay, the total force will be equal to the difference between both the opposite forces. Okay, when both exert the same pressure, then the rope does not move only. This point comes in the game when we play this game sometimes, that the rope is not moving only because here also they are pulling with the same pressure, here also they are pulling with the same pressure. Center thing is going nowhere. Okay. Then force, we know that force may be bigger or smaller than the other force. Okay. Some force may be bigger, that is more powerful, and some may be lesser powerful. Force is measured by its mass. It is necessary to observe the direction and measurement of force. This force acts as work. To measure force, Newton is used. Okay, this is the unit to measure force. N, okay, which is used. If the direction and mass of the force are changed, then the effects are also changed. Force changes the state of stage of motion. Okay. If the direction and mass of the force are changed, effects also change. What does it mean? Suppose now, what happens in that game if they all pull from the same direction? Then, like, not opposite, but the same direction only. Then the rope will definitely go to there only, right? Instead of, yes, Abraham.
But why would they need? Why would all of them need to pull the rope, ma'am? They could just. Why could they just pull? The rope is very light.
The rope is very light. Yes. I am trying to explain the change in direction of the force. Okay. The change in the direction of the force. That depends on from which side are you pulling or pushing something. Okay. Which direction the stronger force is being applied. Okay. Then the mass of the force means how much force you are applying. Okay. How much force is being applied on something. Suppose it's a very, very heavy metal box, and one person metal big metal box, and only one person is pushing it. He is not able to even move it little bit. Okay, five people came, and five people together pushed it in the same direction at the same time. It will move. Okay, why? Because higher forces applied to it. Okay, because higher force is being applied. Five people, force of five people is applied. Okay, so it will push it in one direction. So direction is like it's being pushed in particular direction, and force is also higher. Pressure is higher. That's the direction and mass of force, which are all changed. Then the effects also change. First, the box, the big metal box was static. Then it came into movement. Okay, so the effect also changes. All right, now rate the activity, please, at home today. A football player exerts pressure on a football during penalty kick. Before kick, ball was in rest mode, therefore it has zero motion. Have you seen a penalty kick?
I did
Means
it
that
once.
you did it once. Okay. Do you want to share that example relating it with motion?
I didn't understand.
You don't understand. Okay, it's okay, no problem. So basically, what happens? You place the ball in front of the course, okay, then come and then kick it so that it might go inside the goal post or not. Okay,
Yeah, but you have to kick it in the
basically,
correct
most
direction.
correct direction. Yes, you have to kick it in the correct direction. Now, when the ball is placed in front of the goal post, it has zero motion, okay, because the ball is static. It will not move on its own. The exerted force makes the ball moving towards goal. When the when the player is coming and kicking the ball, a pressure is exerted on it. Okay. High pressure is exerted on the ball, which makes it move towards the goal post. Okay. So goalkeeper stops the ball or pushes it to save the goal. Again, he is applying the opposite force, opposite pressure. Goalkeeper does what? He holds the ball. Like ball is coming in the direction. Okay, he has to stop it. He just holds the ball. Again, pressure force. He's doing it with force. Pressure is there. Opposite pressure is there. So it stops the ball. Okay. If that pressure is higher of the goalkeeper, then it stops the ball which is coming in pressure,
Ma'am,
with coming with force. Yes, Abraham.
one problem is something I think football on the ball comes. If you sometimes the goalkeeper's force will be more, so we will even send the ball flying out into the open
Yes,
instead of catching it.
instead of catching it. Yes, 1 second. Is it true that if I hit the table is pushing back on me with an equal amount of force? With an equal amount of force. That is when you get your foot hit with a table. The table's force hit you. That's you're saying, Simon?
Yeah.
Okay. Yes, Abraham. You wanna add something?
Yes, ma'am. The table will show same amount of force, ma'am, is because like it will show a force is because of friction, ma'am.
Because of friction? Yes, it will show a force because of friction. That's right. Okay. Now, yes. So the goalkeeper exerts force on the moving ball. His force stops or redirects the ball. It also stops the goal. Okay. If the goalkeeper succeeds in stopping the ball, then the motion of ball will be zero. This means that the force exerted on an object can change its path. Okay. If we exert the force on an object, it may change its path. If the pressure exerted by goalkeeper is in the direction of motion of the ball, then speed increases. Okay, if the pressure exerted by goalkeeper is in opposite direction, that speed decreases. Like I said, like force is being applied in the opposite direction by the goalkeeper. It stops the ball. Okay, it will stop the ball. We stop here right now. Okay, give it a read, whatever we studied today. Please do 15.2 exercise as the homework and rest we will continue from stages of motion. We will continue in the next. Okay.